Welcome to yet another episode where we shall be focusing on the mathematics paper 2 for the grade 8s in preparation for our final examinations. Okay, so this is paper 2, grade 8 mathematics. All right, so in this paper we have roughly 5 topics that we're going to be discussing. That's mainly the geometry of 2D shapes, geometry of straight lines. We're going to look at the perimeter and area which is falling under the measurements, and pretty much that would be it. All right, so we're going to start with, there's also the theorem of Pythagoras, but that falls under measurements anyway. Okay, so we have the first question. First question is asking us that we need to determine the value of x. Okay. So question number 1, what type of triangle is this? So this is an isosceles triangle. Okay, so we know that with an isosceles triangle, we have two sides that are equal, which means even the angles that are opposite the equal sides must be the same. So if this is a 30, then that must be a 30. So that is option D. Then 1.2, they're telling us that two angles that add up to 90 degrees, these are called complementary angles. Complementary is option C. Okay, supplementary, they add up to 180. Co-interior, these ones are equal to each other. No, these ones add up to 180, and then corresponding, these ones will be equal to each other. And then 1.3, calculate the missing side. Okay, so if this is a right angle triangle, the big one, ABD, we can start by finding this whole side BD. Let's assume this is not known. So we know that from r squared is equal to x squared plus y squared, whereby r is our longest side, this is our y, and I'm going to call this x, the whole of it. Okay, the whole of it, I'm calling it x. So that's a 10 squared is equal to x, which I don't know. Okay, x, which I don't know, plus my y, which is 8 squared. So I need to subtract. So that's going to be 100 minus 64 is equal to x squared. Then take square roots, which means 36 is going to be x squared. And then when I find the square root, which means the whole length here is going to be a 6. Okay, but this 6 has two sides. We have the CD and then we have the BC. So if this is already a 3, which means this must also be a 3. So option B would make much more sense. 1.4, calculate the perimeter. So we know that perimeter, regardless of the shape, is just a distance that is around the shape, okay? Then if they specifically focus on the rhombus, we know that all the sides of a rhombus are the same. So this is a 12, this is a 12, that is a 12. So it's going to be 12 times 4, which gives us 48. Option C would be the best option. And then 1.5, they're asking us to convert 23 meters squared to centimeters squared. So the conversion factor between meters and centimeters is that 1 meter is equivalent to 100 centimeters. Now, if we are converting 23 meters squared, so which means we're going to multiply by 100 and then multiply by another 100, because the first one represents 1 meter, other one is also representing another meter. So that gives us 230,000 centimeters squared, which is option A. Then question 2, they want us to calculate the size of the unknown variables. Now, what shape do we have here? This is a triangle, and the x that they're talking about is an angle. So we know that angles in a triangle, okay, angles in a triangle must add up to 180 degrees, which means if we get 50 plus 68 plus the x, it must give us 180. Now, with this question, it is a must for you to write your statements, but also give the reasons. Okay, so we're saying 50 plus 68 plus x must give us 180. So this is the statement. And the reason, we're going to say that angles in a triangle, or you can say the angle sum of a triangle, So whichever reason, you can even write it in full words, okay? Then we add these two, so 50 and 68 gives us 118 plus x must give us 180. Then we move this 118 that side so that we look for x. So 180 minus 118, what do we get? Is it a 62? So x becomes 62 degrees. Please do not get a protractor and measure this. We just need to do the calculations because these diagrams in most cases are not drawn to scale. 2.1.2, they want us to calculate the size of y while giving reasons. So what we need to do is we're seeing this as a 20. We're seeing this as 70. So 20 and 70, both are interior angles because they are inside of the triangle. But this y is exterior, okay? And the connection between the interior and exterior is that one exterior angle must be equivalent to two interior angles that are opposite to it. So which means y is going to be 20 plus 70. And the reason is going to be exterior angle of a triangle. Okay, so 20 plus 70, we end up with a 90. So these two must give us 90 degrees. All right. Then 2.2 is ABC with those three lines. So those three lines simply represent what we call congruent. Okay, congruent is a scenario where shapes are identical, exactly the same. They have the same characteristics, they have the same features in terms of lengths and also the angles. They have to be exactly the same, okay? So it's like having two blue markers, okay, of the same model, of the same making. Those two will be identical. They will be congruent. So is ABC congruent to EDC? You must answer yes, and you must give a reason. So what we can see is that there is angle A here with the same marking as angle E. We're seeing this sign of AC and CE, which means these two are equal. But we also know that C2 and C1, they're also equal. Those are vertically opposite. So we can, let me just break it down and say that C1 is the same as C2. Reason is going to be vertically opposite angles. Then I can say that A is the same as E. We're going to say given because we were told. And then we're saying that AC, two letters represent the length of the distance, is the same as CE. This is also given. So we have three facts that prove that these two triangles are exactly the same. So we're going to say yes. And the reason is going to be this is an angle and then the side and also an angle. So we're going to say angle, side, angle. All right, then that is 2.2. Then 2.3, in the diagram below, they're telling us that CS is parallel. Okay, these two lines represents parallel. Those two lines represent parallel lines, okay? EAW, the angle in the middle, 70. This is the same as that, okay? And then CA is X, this one. Can we give a reason why E2 is the same as X? So for as long as we have the parallel lines, we can see that those two angles are forming what we call a Z, okay? So the reason is going to be those are alternate angles because CS is parallel to HN. So that is the reason that we must give. Then hence calculate the value of X. So one thing we know is that W1 is also going to be X because now this triangle AEW is isosceles. So if this side is equal to that side, which means this angle must also be equal to that angle. So it's going to be angles that are opposite equal sides. All right, so then I'll have X plus another X plus 70 should be equivalent to 180 because now I'm looking at all the angles that are within a triangle. So we're going to say angles in a triangle. So X and X is 2X. Let's move the 70 that side. It's going to be 180 minus 70, which means 2x is 110. Then let's divide both sides by 2, which means x becomes a 55 degree. All right. Then they want us to get the value of E1. Where is E1? E1 is this angle here. So what we can do then, you have a choice now since you have your x as a 55. You can find your E1 by looking at this 70 and this 55 also, and then we form the exterior angle. Alternatively, you can look at the E1 and the E2, then those will be angles on a line. So the quick one will be E1 is equal to 70 plus 20, is it 55? That gives me 100 and then 25. So the reason here is going to be the exterior angle of a triangle. Okay, so alternatively, we said you can use E1 and E2, which is 55 plus E2 must give us 180. That's going to be angles on a line. Alternatively, we can use the reason of supplementary angles. So it's adjacent supplementary angles. So when you subtract 55 from 180, you still get your 125. Same marks, okay? Then identify the name for AEW. AEW. So this is an isosceles triangle. It's a triangle with two sides that are equal. So it's an isosceles triangle. All right, so that is question number 2. Question number 3. They're telling us that AB, remember the two lines? Parallel. When we talk about parallel, those lines are equidistant. So what is the relationship between x and y? So we're seeing that x and y. So those ones are vertically opposite angles. Vertically opposite angles, because we can see from that. Then what is the reason? X and z could be equal. So x is here, z is here. So we have the z or the n. Okay, the n represents the alternate. So alternate angles, because AB is parallel to CD. Then 3.2, if ABC is a straight line, they want us to get the value of x with reasons. Okay. So the statement that we need to know is that for as long as we have angles that are on a straight line, if there are 2, the sum of those 2 angles must be equal to 180. If there are 3, the sum of those 3 angles must be equal to 180. So I'm going to say 55 plus x must give us 180. This is going to be the adjacent supplementary angles. Okay, adjacent simply meaning that next to each other, but they are lying on a straight line. Then for us to get the x, we move the 55 that side, which is going to be 180 minus 55. So 180 minus 55, that's going to be 125 degrees. So that for 3 marks. Okay, you leave out the reason, you're going to lose some marks. 3.3, calculate with reasons the value of A, B, and C. Okay, so we still have parallel lines, because AB is parallel to CD. So we're seeing that if we have 1 of 5 here, how does A relate with 1 of 5? We can see that they are just vertically opposite because this line is intersecting with this one. Okay, so we're going to say that A is 1 of 5. Reason, these are angles, vertically opposite angles. Then if that is 1 of 5, if A is 1 of 5, they want us to get B. What I can see is that this A and B, they are within the parallel lines. It forms the U or the C. So which means those are co-interior angles. So if I get the 1 of 5 plus the B, I must get 180 degrees. I'll say those are co-interior angles because AB is parallel to CD. Then I subtract. Okay, so my B is going to be 180 minus 105. This gives me 75 degrees. And then for me to get C, so if B is a 75, which means C must also be 75, because that will be corresponding. Okay. How do we see that it's corresponding? We can see that it's forming the F. If it's the F, which means this must also be equal to that. Alternatively, if you don't want to do it that way, you can look at C and the 105 to be adjacent. So 105 plus C must give us 180 adjacent supplementary angles. So 180 minus 105, we shall get 75 degrees. All right, so that is how 3.3 would be answered. Then 3.4. The diagram below, we are still dealing with parallel lines. Calculate the value of x, y with reasons. Okay. 2 marks for x. So how does x relate with 60? How does x relate with 80? So there's no link between x and 60, but I can find a link between 80 and x because there's a z or there's n. Okay, if that is true, which means x is going to be 80. Those are alternate angles because AC is parallel to BD. AC is parallel to BD. That is for the x. Then y, I'm seeing this component of y. It has no relationship with x. They cannot be co-interior because this line is not parallel to this one. But I can see that they are equal to the 60. This y is equal to 60 because these two are forming the F, which is corresponding. All right, so what I'm going to do, I'm going to say that we know that corresponding angles must be equal. Y plus 10 must give us 16. Those are corresponding angles because AC is parallel to BD. Then let's move the 10 that side. That's going to be 60 minus 10, which gives us a 50 as our answer for that case. All right, then question number 4. We have the theorem of Pythagoras. They're telling us that AB is 20 units, AC is 12, and then AD is 15. Okay. Calculate giving reasons the value of x. So if we look at x, since it's Pythagoras, we know that Pythagoras is the theorem that deals with just triangles that have 90 degrees. If it doesn't have 90 degrees, we have no business with it. So let's focus on triangle ABC. Okay, so from ABC, we can see that r squared is equal to x squared plus y squared. Our r being the longest side. Longest side is always opposite the 90 degrees. So that's our x. This is our y. In this case, okay, just for this triangle. Or you can use p squared is equal to q squared plus and so on and so forth, okay? So that's going to be 20 squared is equal to x squared plus 12 squared, okay? 20 squared is 400. I need to subtract this, which is 144. That is x squared. So 400 and then 144, that's going to be 6. It's going to be a 9. Okay, so I'm going to have x squared is 256. And then the square root of this, is it 14? That's 16. That's 5. That's a 4. That's a 1. No. So that is 16. Okay, so x becomes 16 units. Okay, then 4.2, they want us to get the value of y. So value of y, I mean, why are we even calculating it? They told us AD is the y, which is 15 units. So you can use your theorem of Pythagoras and tell us that your y squared is equal to 12 squared plus the 9 squared. So 144 plus 81. Is that true? Yes, we get 225. And then square root of that gives us the 15. All right. Then hence determine the length of BD. So we know that BD is the total distance. Okay, so BD is the BC and then the CD. We already have this as a 16. So which means our BD is going to be 16 plus 9, which must give us 25 units. All right, and lastly, question number 5. Consider the triangle ABC with B90, AC is 13, BC is 5, and AB is 12. They want us to get the perimeter of the triangle. Remember, we say perimeter is the total distance around the shape. So AB plus BC plus AC. So that's going to be 12 plus 5 plus 13. So that's 15, which gives me 30 centimeters. Then they want the area using this formula. So the base and the height are the sides that form the 90. So 90 is formed by this and then that. So this can be our height. This can be our base. So it's going to be a half times 5 times 12. Okay, so this is the same as 60 over 2, which also gives us 30 centimeters squared. So area is in square units, whereas perimeter is just plane units. Then 5.2, study the circle below and answer the questions that follow. The diameter is 42 millimeters. Determine the radius. So radius is basically the distance from the center of the circle to the circumference. Okay, from the center to the circumference. So half of the diameter gives us the radius. Okay, so radius is diameter divided by 2, which is 42 divided by 2. This gives us 21 millimeters. Then 5.2.2, they want us to get the area of the circle using that formula. So we know that the area is given as pi times the radius squared. 3,142 times 21 squared. Okay, so if we are to punch that into our calculator, okay, this would be the same as 3,142 times 21 times 21. Okay, 3,142 times 21 times 21. I end up with 1385.62. This is millimeters squared, since it is area. And that brings us to the end of paper 2. But remember, there's quite a lot under these measurements, where they can even ask you for the area of the shaded part. They can bring in questions to do with the quadrilaterals and so on and so forth. Thank you guys for watching, and then I wish you a safe and fruitful preparation for mathematics, paper 1 and paper 2. All the best, guys. Bye-bye.